Yeah, assalamu alaikum, and here you go, your PowerPoint file that you have sent me related to your lecture that you have just missed, and it deals with the basic preliminary discussion related to your correlation and regression. So you can see here that in the beginning they have discussed the scattered plots, and after that they have given you an example related to the scattered plots. Then after that they have just explained you how you plot the scatter diagram by using these two quantities, age and the pressure, like that. And then they have explained you the types of scattered plots, a positive and the negative, and on the basis of this regression scattered plotting, they have explained you the correlation terminology. Okay, so correlation is basically what it is, something that you say, a method of expressing the dependency or interdependency between the two quantities that you are discussing in your whatever the assignment is and whatever the experiment that you are conducting. So hang on, I'm using my father's cell because over here the app of PowerPoint was there. So okay, so first of all, what exactly you need to understand is the regression concept, how to plot the regression line, and what exactly a scattered graphing is. And on that basis, once the concept of regression will get clear to you, then you move ahead to the correlation. Okay, so in the beginning, let's start how we understand the scattered plots. And over here, I'm not using your example, I'm using my own example that I've used in my own book that I'm writing these days. So let's move ahead and see how that example is going to help you out in understanding the scattered plots and then the regression. Okay, so here you go. Okay, now here you can see that I have maintained a table of the production of your wheat and rice, and here the quantity of wheat and rice is expressed here in X and Y, and they are actually in thousands of tons. Okay, so this X is representing the production of your wheat in 1,000 tons, and this Y is explaining you the production of rice in 1,000 tons in these subsequent or consecutive years from 2005 to the year 2013. Okay, so here you can see the table is given to you of this bivariate stuff, the rice and the wheat, 23,000 ton, 39,000 ton, and so on. So you have to do what? You have to establish a relationship between, you have to understand actually the relationship between the production of rice and wheat. And it is that if the production of rice is increasing, is the production of wheat is also increasing or not? Okay, or if the production of rice is increasing, then if the wheat production is decreasing. So you see, you have to understand, is there a direct relationship between the two quantities or the inverse relationship between the two quantities? So what exactly a direct relationship is, just understand this theoretically, then we move ahead to the graph plotting. So if one quantity is increasing and the other one is also increasing, then you say that the two quantities are directly proportional. Or in other words, you can say if the two quantities are directly proportional, that if one is increasing, the other one is also decreasing. So you see, both quantities should show the same behavior. If one is increasing, other one should also increase. If one is decreasing, the other one should also decrease. Then you say that the two quantities are directly relationship or directly proportional to each other. On the other hand, if one quantity is increasing and the other one is decreasing, then you say that these two quantities are inversely proportional to each other. Okay, and if you are not having both such kind of relationship, then you say that they are not related at all. There is no proportionality between them. So let us now understand that how we connect these two quantities by drawing a scattered graph or by drawing a scattered plot. Okay, so let's have a look and let's plot these two quantities on the graph in such a way that on the x-axis you are going to take the production of wheat, and on the y-axis you can take the production of your rice, and then you are going to plot these points. So how we are going to do it, let's see. It's just a basic thing that we study in the lower secondary classes. If you just recall, I hope you wouldn't find much difficulty in understanding that. So let's have a look at the figure. Yes, so now I hope you can see the plotting that I have just done over here. On the x-axis, I have just taken the wheat production in thousands of tons, and on the y-axis, I have just taken the rice production in thousands of tons. Okay, and you can see that these points are right over here. The x represents the value of your rice production, and the y variable is representing the I'm sorry, I've just changed. X is representing the wheat production and Y is representing the rice production. Okay, so here you can see that this is what this is. You can take that this is your 23, just right. This is your 23, and over here your 16 must lie in the middle of this 10 and 20. So this is a crude estimation, and you just see that your first point is lying over here, and we just made a cross. Okay, now see the second reading. The second reading is wheat is 39 and your rice is 30. Okay, so let's see, where is your 30 and 40. 39 might be over here, and over here somewhere, and 19 might be somewhere here. Okay, so this thing tells that the point is exactly at this point. Okay, this is your 39 and this is your 30. Okay, yeah, this is the point. So you see, in the same manner, you're going to plot your remaining points, the 19 and the 12. Let's see the third point. You see the 19 is over here, close, right over here, and then 12 is on the x-axis. The 12 is right above your 10 somewhere. Okay, so it is this is the point, 19 and 12. So that's how you plot all these relative x and corresponding y points. So you can see, once you have just plotted all these points, they are moving ahead uphill to right. Okay, like that. So they are basically not in the straight line, but they are approximately, they are making a very strong band moving ahead to the right, upwards to the right side. Okay, so if you just try to draw a straight line, so you can see that the straight line so drawn over here is going to cover majority of these points, and that line we call the line of best estimate, a line around which the majority of the points are getting clustered. Okay, so that line is said to be the line of the best fit. So when you try to draw line of the best fit, you will see that line is going to be moving uphill towards right, means it's supposed to have a positive slope. Okay, so once the band of these points is quite strong, you can see it is quite concentrated and it is moving upwards to the right side. So if you are having such kind of relationship after drawing the scattered plot, then you will say that these two quantities are directly correlated to each other. Okay, this is a regression band. Okay, and if the regression band is quite concentrated and is moving ahead upwards to the right, so you will say that this is a positive correlation and a positive regression line, explaining you that these two quantities, the wheat production and the rice production, are directly related to each other. Means if the wheat quantity is increasing, then the production of the rice is also increasing, and if the production of wheat is decreasing, then the production of rice is also decreasing. It is explaining you that thing. So it could be on the basis that perhaps they are using some good seeds and good fertilizers and good machinery and good agricultural sciences, all that. So that might be the reason that if the one production is increasing, that other one is obviously it is also increasing, because they might be using the same methodology of the development and harvesting and cultivating and all that. So that's how you maintain the relationship between the two quantities. Okay, so and you see this scattered plot is explaining you the type of relationship between these two quantities. Okay, so scattered plot help you in understanding the correlation, and this plotting is something that you call a regression plotting. Okay, so regression is the geometrical interpretation or graphical interpretation or graphical explanation of correlation between the two quantities. Okay, so that's it. Let's move ahead and see the other types of your regression when the regression is negative, because up till now you have just studied that this is the way how you explain the positive and strong regression. Okay, so this is a positive and strong regression belt, and it is explaining you that the two quantities are positively and very strongly directly related to each other. So this is one type of your correlation on the basis of this band. Okay, so and one thing more that I need to share, that if you're having a line like this, you're plotting and you're having a straight line like this, so and this line is going uphill to right, then the slope is always of such lines is always taken positive, and it comes out to be positive. We have mathematical explanation over here. And if your line is drawn in this way, if it is plotted in this way, then you will say that it is moving downhill to right, so such a line has a slope of negative value. Okay, so if slope of any straight line comes negative, you say it is telling you the retrogression, or it is telling you the downfall of the two quantities, and or it explains you the inverse relationship between the two quantities. So you can see that if one quantity is less, then the other one is quite higher, and if the one quantity is increasing, the other one is decreasing, you can say. So such relationship which is explaining the inverse relationship, that one quantity is increasing and the other one is decreasing, that it is going to represent a line or a regression belt which is so drawn in this way, moving downhill to right, means it contains a negative slope. Okay, and if you're having two quantities which are directly related to each other, that is, if one quantity is decreasing, then the other one is also decreasing. If one quantity is increasing ahead, the other one is also increasing ahead, having such kind of point, you're going to have a regression belt moving uphill to right. So it is going to have a best fit of line moving uphill to right. So such line or a straight line so drawn on the meaning of the best fit is going to have a positive slope. So let's move ahead and see the other types of scattered plots. Now let's see another a general example. On the y-axis you have plotted one quantity, on the x-axis you have plotted another quantity, and you want to find out what is there any kind of relationship between these two quantities. And once when you plot the corresponding points or the corresponding ordered pair, so you see if I just talk about this table, you can see the x corresponding value of x is representing this value for the y. So you see, if I just try to write these points in this style, in this style, okay, so such kind of representation is called the ordered pair representation of two tuples. Okay, so in other words, so if at times if I just say that I'm plotting the ordered pair, so it should be understood in this way, that I'm plotting two quantities expressed in the ordered pair. Okay, so if the subjective here, if the production of one quantity is this, then the production of the other quantity is this. So that's how you just plot the relative ordered pair points in on the graph paper. So you can see here, once you are plotting your graph on a two-dimensional plane, that's why the points are lying on a plane, and plane is a two-dimensional space. So all the points which are lying on the 2D are expressed with respect to the length and breadth. So they are expressed in the ordered pair of two tuples. So this is basically one point representing two dimensions. Okay, it is taken in that sense. So let's see this graph over here. Okay, so here on the x-axis I've taken one quantity, on the y-axis another quantity, and I have just plotted the corresponding ordered pairs like this. Okay, but this is just a crude way of understanding, it's just a rough example. So you can see that all the points that is given to me in the subjective data is so plotted in this way. So you can see that this band is concentrated quite much, and it is quite collapsed band, a strong band. You can see it is not much wider, it is quite narrow band, though it is not linear, but it is quite clustered, and it is drawn from downhill to right. Okay, it is moving downhill towards right like this. So if I just try to draw a straight line that is said to be the line of the best fit, then it is going to be drawn like this, covering the majority of the points getting clustered around it. Okay, so this line of best fit is actually downhill to right. So you can see that if one quantity is over here, and the corresponding other quantity is plotted over here, it's quite higher value. Means if this quantity is less, then the corresponding y quantity is quite higher. And once when you see that this quantity keeps on increasing or moving ahead towards right, it is increasing, so the corresponding value of this point is quite less, it is over here. Okay, so once this quantity is increasing, the other quantity is decreasing. Okay, so this is an inverse correlation, or in other words, you can say that this is a negative correlation, because the regression band is expressing the line of the best fit, which is drawn downhill to right, and the lines which are drawn downhill to right, you can see, contain a negative slope. Okay, it contains a negative slope. So such quantities which are expressing the regression band drawn in this way, then you will say, and it is a collapsed one, so you will say that this is representing a strong negative correlation. Okay, this is one type. And let's move ahead to the another explanation related to the weak correlation between the two quantities, how the regression band is drawn over there. Let's see. It's getting too blurry. Okay, now let's have a look to this another example. I don't know why it's getting too much blurry, not focusing properly. Anyways, you have to just have a tranquility on that. And you see now you are having these points, these are the crosses actually, they're quite getting too much blurry. So these are the two quantities that are so represented on the positive and the x-axis, on the positive y and x-axis, and you just plot the subjective ordered pairs on this graph, and you just obtain quite the points which are quite scattered. Okay, you can see there is a quite broad regression band, you can see, and the direction of this band is uphill to right. Okay, so though the band is quite expanded, it is not much concentrated, not collapsed one, just like the previous one that we have discussed. This one is quite broad, and you can see that the points are very much scattered. Okay, these points are quite scattered. So this explains that though the band is moving uphill to right, but the points are very much scattered, they are not clustered, they are not forming a very thin band. So this explains that there is a correlation between these two quantities, there is an interdependency between these two quantities, but it is quite weak. Okay, so this correlation is positive, but a weak correlation between these 2 points. So this is something that we have observed on the basis of this scattered plots. The points are very much scattered, so this explains you that the dependency between two quantities is quite weak. It does exist, but it is quite weak. So now let's see the relationship which is negative and weak. So let's see another example related to it. Now here you can see that if I take a set of data and I just try to plot those data ordered pairs related to the two different quantities on a plane, then you see that I'm having points which are drawn in the form of a broad belt, Okay, this is a broad belt, and the points are quite scattered, and collectively or combinedly they are giving you an effect that they are drawn downhill to right. Okay, they are plotted, or this band, the direction of this band is downhill to right. So this tells that the relationship between the two corresponding quantities is quite weak and it is negative in nature. Okay, because the direction of the band is downhill to right, so the slope is negative. So you see that the relationship between the two quantities, or the correlation between the two quantities, or interdependency between the two quantities is negative and weak. Why it is weak? Because you can see that the points are very much scattered. They are not collapsed. They are not clustered in the form of a thin band. It is representing quite broad band. So this thing shows that the dependency or the correlation between the two quantities does exist, but it is quite weak. And it is negative because it is moving downwards. If the one quantity is increasing, the other one is decreasing. It is like that. So as far as the line of best fit is concerned, you just try to draw a line in a best possible way, such that it covers it contains majority of the point on it, and the remaining points must not be far away from it. Means the remaining point must be as much closer to it, or it must be very much clustered to it. So you have to draw the line of the best fit on your own choice, on the basis of your best analysis, that can cover majority of the points on it, and the remaining points which are not lying on it should be at least very much close to it. So that line is said to be the line of the best fit, and once it is going to be drawn in the form of a straight line, it is a straight line. So it definitely is going to be expressed with this equation: y is equals to mx plus c. And this is the equation of the straight line, you can see, and this c is said to be the y-intercept, m is the slope that we are going to study with a suitable example, so it will get very much strongly clear to you. So up till now we have just studied the types of the correlation on the basis of the regression band, or on the basis of the regression line of best fit. Okay, after that, now in the next video we are going to discuss the line of the best fit, and after that we are going to approach to the coefficient of the correlation. And over there, the formula that you have just that is given in your over here, that is given in your slide, this formula regarding to which you were asking me about the summation sign, this thing, it is still blurry. So that formula is actually the Carl Pearson coefficient of correlation formula, and over there you are going to study how you're going to use it in your numerical basis, on your numerical analysis. Okay, so we'll see it in the next video.